The formulas for variance and standard deviation in a simple frequency distribution are very similar to the raw score formula for a set of scores. As you'll notice on the formula over here, the only difference is the addition now of an f for the frequency variable. And so here is a simple frequency distribution, and the scores range from 1 to 8, and in this column are the frequencies of the scores. And I've already created what's called an f times x column in order to calculate the mean for this distribution, which I've done right there. In looking at the formula, we see f times x squared. So does that mean that we just square the fx column? I have an fx column and I should just square it, right? But that is not correct. According to the order of operations, exponents come before multiplication, and so we must square each x first before multiplying it by f, its frequency. So I've created an x squared column, so I'll simply type an equal sign, and I will click the first score plus the caret and a 2 to square the first score of 64, and I'll do that for the rest of the scores as well. My next step is going to be to multiply each of the squared scores by the frequency. So I'll set up a calculation for that. And I'll drag down to the other scores. Just for grins, let's see what would happen if we squared the frequency times the score. We multiplied the frequency times the score first and then squared that product. So, in other words, I'm taking fx, 16, and I'm squaring that number. And I'll drag it down to the other values. As you can see, simply squaring fx gives you much different responses than if we timed the frequency times the squared scores. So this is what we want to do, not this. I'm going to get rid of this. Okay. All right. I'll now sum this column, which will give us the numerator for our calculation. And we end up with the number 988. I'm going to feed that into our formula. Variance equals the sum of the frequencies times the squared scores over the n, which is 40, minus the mean squared. So I'm going to put the caret and the 2 to indicate that it should be squared. We end up with a variance of 3.54. And just as before, the standard deviation is going to be the square root of the variance. So I'm going to insert the function for square root and enter the variance. And we have a standard deviation of 1.88. This score tells us that on average, the scores in this simple frequency distribution deviate from the mean by approximately 1.88 units. I suggest you work on practicing items 3 and 4 on your practice for this week after the video, and then watch the last video where I will discuss calculating variance and standard deviation in a grouped frequency distribution.